One of the chief problems which we face today in terms of visualization, it is access to images, as we saw earlier. This raises issues of format, of file sizes. The idea is to make them accessible to everyone. From the small pane that we have here, or an idea of having a more severe problem and having to see first a specialist and then the radiologist. The radiologist is going to supply images that he will send back to the specialist. The specialist will send back the information to the patients. The patient has a question, raises himself questions. We make a first diagnosis and we send the patient to the OR. This is the pathway. It can take place from weeks up to months everywhere, not only in France, in Switzerland or China, everywhere. And the idea is to shorten these steps which go from the diagnosis, also educating the patients so that he or she understands what she has or hasn't, the pre-op steps and surgery. So in the first step, we have to consider the expertise of the physician. Also, we have to have a radiologist available. We have a shortage of radiologists. There are hospitals in Paris where you have more CT scan machines than radiologists. The analysis deadlines are very long, and it's of concern. So the idea is to shorten this pathway with 3D modeling, which is fast and accessible to everybody with 3D impression. But if we put this in perspective with the whole cost of the surgery procedure, which costs between 1,500, 1,500 and 2,000 euros per hour, and a 3D impression can cost 300 euros. And if we can shorten the procedure by 1 hour, it's a good saving. So we are focusing on remote data access. We've created the clouds with Microsoft, where we can access without any plugging, without any obstacle. You can receive the links on your mobile phone, on your tablet and whatnot, with a good quality. So once we have access to image, we will also be able to consider 3D impression. Today, 3D impression is available to each and every one. We are printing a maxillary bone. This is to train people to implantation. So it's a strata per strata impression, then it's gluing to glue together, and the models are ready to be used for a training. The quality of the models are such that we can visualize them quickly. Generally, it takes 70 hours between the time when I send out the model to the cloud and the printing time. We can do it slide by slide, so I can visualize the different slides stacking up. Then we need to have the expertise. We have to explain the patient what he suffers from and what treatment is going to be offered. 3D printing is also interesting because we have the sensation. The object is created at scale 1, and we know what we're talking about. Here, for example, this is for quite a severe deformity of the spine. We will consider surgery, and we will present the different steps to the patient in order to treat his condition. Then there is the preparation before surgery. The concern is what strategy to consider, how long it will take, the exchange, the dialogues between the different specialists. If we were using the same tool for everybody, here this is a 3D impression for rhinoplasty. This is specialist operating on. It's really realistic. The surgeon has the feedback control control, the touch control, and the surgeon can do demos before in front of audience without having to bring a patient. He can illustrate the different procedure, techniques, and strategies for this type of operation. This is to train surgeons for implantation. The quality of the print is critical. If the examination has been performed with a high resolution, you really have the exact control feedback which you will encounter. It will abut exactly where it will abut in real time. If you feel lack of material, it is due to bone porosity. So we talked about 3D impression, but what we can do also, for the sake of the surgeon, he wants to have access to information, and he may want to move on to enhanced reality. As Professor Sylvain Ordureau presented projections on the patient, and here we have new techniques which, thanks to these goggles, which you will be able to try them on. You can download the the exam, and once the film is downloaded, we can recalibrate this on the patient. Of course, this is not the real patient, but it's just to give you an idea about what we are developing nowadays with the surgeon worldwide. We work with GE, all the groups that manufacture the radiological equipment to be able to do recalibration and having these feelings of being able to see through the patient with C-arms and bone scans and whatnot. The image is impressive, but it's really in real time, it's absolutely flabbergasting. I'm showing the pathway of a real patient. Here, I have a small tumor on the zygomatic bone, and if I do not do anything, the tumor is going to propagate to the eye and is likely to lose his eyesight. So we'll do a 3D printing. You can see these labels. This is not science-fi. You have patience. You can print out the model, and within 12 hours, you will obtain the model. So the surgeon, the orthopedist, will be able to cut out these areas, position them, have a titanium printing of the missing part, and intervene. So it shortens the intervention deadline. This model may cost 500 euros, but the procedure lead time is extremely shortened, and the quality is really excellent. It's highly realistic. So we have both access to a remote examination and real-time examination. So 3D printing is for sensation, and the model itself is to be able to exchange and communicate. So I'm going to start to schedule a live demo. So the principle is as follows. I'm switching on the goggles. Normally, we should have an image on the screen. So I'm putting this on my nose. There is a little wheel in order to adjust the position. So when you will have an opportunity to try it on later on. So what I see a menu in front of me, and I can scan the environment, and the detector will identify the whole environment, and the picture is very stable. I'm going to start the application. There is a recognition of the movements. The window is positioning, and the screen is stationary. And I'm going to navigate through the exams. I'm going to choose a whole body scan This is instantaneous. And the secret is nothing is calculated into the goggles. Everything is calculated remotely from a calculation cloud. My specialty is computing. So I can walk around the patient. I'm really standing next to the patient, and there is vocal recognition so that my hands are free to do something else, and I'm going to say, move. And he answered, we move on to translation mode, and I can do something like huge, can say something like huge, and then he takes up this huge shape. Reset scaling. My accent is not good enough for ordering for the system to understand my orders. So, and I'm going to show you an even more interesting exam, a beating heart. Most of the radiological workstation could not process so many images, but we are calculating in the cloud. We don't need to have a powerful computer, just the goggles and a good Wi-Fi connection. So I can see the heart, I can rotate it like this, and you have a screen return, and I can cut inside. I can see all the structure, and the heart is really beating. In the future, I will be able to do examinations, first-line examination, store good quality exams, and reposition it on the patient. I'm showing a last one here. And also archaeology. Archaeologists like to use these systems. So the tumor, which I am going to show in 3D print, bigger. This is my order. Zoom in. He's not paying much attention to me. So as you see, I can see everything inside. So if you want to try the goggles and touch this 3D print object, come and see me soon after the conference, and I will have great pleasure in giving you this object to handle. I do not know whether the audience has any questions for Mr. Ordureau. Any questions? No question. So the problem with things developed with vocal controls, commands in English, they don't work with the French accent. Very soon I'm traveling to Japan, and saying rotate in Japanese will be a problem for me. And WhatsApp, the system apparently doesn't understand Swiss German either. So I'll invite you all to go and test these machines afterwards.